So another physical application we will look at is finding the mass of a rod. We lay the rod on the interval so that it's covering the x-axis from x equals a to x equals b. If the density were constant, then the mass would just be the density times the length. But if the density is given by a function, then to find the mass, we take the definite integral from a to b of rho of x dx. So it's not too hard to find the mass using this definite integral, and this is a physical application of integration. So a thin rod is oriented on the x-axis from x equals 1 to x equals 3. We're told the density function is rho of x equals 1 over x.
What is the mass of the rod? Here we need to find the definite integral from 1 to 3 of 1 over x. When we find an antiderivative of 1 over x, remember that this antiderivative is natural log of x. It's the lone oddball that doesn't fit the power rule pattern. Into the natural log of x and subtract. This gives natural log of 3 minus natural log of 1. Since natural log of 1 is 0, the final answer is natural log of 3. The second example gives a similar problem. Here we have a thin rod oriented on the x-axis on the interval from 2 to 3.2. If the density of the rod is given by the function rho of x equals 5x plus pi, what is the mass of the rod? It's straightforward here to find the definite integral from 2 to 3.2 of 5x plus pi. An antiderivative is 5 over 2 times x squared plus pi times x. So we simply evaluate the antiderivative we found at the endpoints. This gives quantity 5 over 2 times 3.2 squared plus pi times 3.2 minus quantity 5 over 2 times 2 squared plus pi times 2. Please don't use a calculator. If you want, you can simplify this using a computer.